Okay, so we have learned about composition of function. Now we are going to learn about something called inverse function. Let's look at this special example where f and g are the same, 1 of x, 1 over x. What's f of g of x? You can pause the video and try evaluate this yourself. It's f of 1 over x, which is 1 over 1 over x, which is x. Similarly, g of f of x is g of 1 over x, which also is 1 over 1 over x, which is x. Let's see this one, f of g of x is f of x minus 3, which becomes x minus 3 plus 3, which is x. G of f of x is g of x plus 3, which then becomes x plus 3 minus 3, which is x. So what's happening here is, in all of these, we end up with x in the end. And this is a special case, because what's happening if you draw the diagram is you're feeding x into f, it throws out f of x, which feeds into g, and you get back x. So this hasn't changed. This is called a special case. This is what's happening. When this happens, the functions f and g are called inverses of each other. Effectively, what they do is they undo each other. It's like opening a door, closing a door. Yeah, wearing socks, putting socks off. So when two things undo each other, then they are called inverses of each other. Example, show that the following functions are inverses of each other. So what we need is, we need to show that f of g of x, we need to find this, and we need to find this. Now that's f of x over 7, which is x. That's good. This is g of 7x, which is 7x over 7, which is x. That's good too. Similarly for these, again, f of x minus 2 over 3 is 3 times x minus 2 over 3 plus 2, which is x. G of 3x plus 2 is 3x plus 2 minus 2 over 3, which is 3x over 3, which is x. So they are inverses. I'm going to skip this one, let you work on this. I'm going to do this. F of g of x is f of cube root of x minus 1, which becomes cube root of x minus 1 cubed plus 1. We know these cancel from the previous chapter, and gives me back x. G of f of x, on the other hand, is going to be g of x cubed plus 1, which is cube root of x cubed plus 1 minus 1 cube root of x cubed, which is x. So in conclusion, to show fx and gx are inverses of each other, we need to show that f of g of x equals g of f of x equals x. That's the necessary and sufficient condition for something to be inverses of each other. In the next video, we're going to explore some other questions